Okay, number 9. Central High School had 5 members on their swim team in 2010. I recommend let's annotate. So I highlight the fact that there's 5 members on the team. Over the next several years, the team increased by an average of 10 members per year, so I underline my increase. The same school had 35 members in their chorus in 2010. The chorus saw an increase of 5 members per year. So now I've got my systems organized so I know which one goes with which, and we can write our system of equations to model the situation. So I start with y equals, and I know that the swim team started with 5 members. So I'm just going to grab my 5 and say plus 5. How they're changing, the slope is 10 members every year. So that 10 goes with my x. So y equals 10x plus 5. That's my first equation. Now for my second equation, we're back to y equals again. And they started with 35 members. So we're going to have our plus 35. But this time our slope is only increasing by 5. So we have 5x. So when we talk about increase in numbers, I know that this team started with 35. So my y-axis needs to be fairly large, and my x-axis is just going up by 1 year at a time. So the first thing we want to do with this graph is label our axes. So sometimes we have to be a little bit creative with our scales. My scale for my x-axis, I'm counting 1 year at a time, and I labeled every 5 years to help stay organized so I don't junk up the graph. Now, when we're talking about members, I started counting by 5s, and I labeled every 5 5s. So 5 times 5 is 25, 50, 75, and then up to 100. Now, I want to make my graphing calculator look exactly like this window. So, home screen, new dot, say no to drugs, and add a graph page. So, before I graph a function, I want to make my window. So, menu 4, 1. That's a custom window. My x-axis is going from 0 to 20, counting by 1s. My y-axis is going from 0 to 100 and counting by 5s. Now we can graph our first function. So we start with f1 of x. That's the same exact thing as y equals. I don't have to get rid of f1 of x. I can just type the other side of the equal sign from there and say 10x plus 5. And there's my equation in y equals form. Now, to get my command line back, I just press tab. Now our second equation, we're only increasing by 5, so it's 5x, but we started with 35. And that's our two equations. So now I need to graph these points. Menu, 5 for trace, 3 for trace step. Always set the trace step to 1 because we want our inputs counting by 1s. Now, when I do menu 5, 1, I can find the points on my graph. So the points I really care about, I start at 0, 5, 115, 225, 335, and so on. So now I can take those points, plot them directly on my paper graph, and then move on to the next equation. Sometimes it can be really annoying to switch from one graph to another. So the easy way to solve that problem is let's do a trace all. So just hit escape, make sure that we cleared what we're doing, and then do menu 5, 2. By doing a trace all, we've got two different graphs. So now I can look at the red line instead of the blue line. So I start at 0.35 and I'm going up by 5. So 140, 245, 350, 455. And I trace this line and I get all the points on that graph. Now, notice for both graphs, I definitely have the y-intercepts plotted. I have another point at the other extreme end plotted. And now I want to recognize exactly where these two graphs meet. So if I go back to my calculator, as I approach our point of intersection on this graph, these values get closer together. And notice when I get to 665, that's a point on both lines. Therefore, 665 is the solution to this system of linear equations. We want this point to stand out because that's why we did all this work, is to find out that both of these lines intersect at the point 665. Now, to get the last 2 points for our question, we need to explain what this point of intersection means in context of the problem. So we start with the x-coordinate represents the number of years. So if we add 6 to 2010, we get 2016. So in 2016, both the chorus and the swim team had 65 members. And that's our last 2 points for this system. Because remember, this is the big one. This was 37 on this exam. 6-point question takes a little bit of work, but when you get in there and do everything, it's worth it.